Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video we'll discuss about question number 24, NEET Physics paper 2015. Friends, number 24, a certain metallic surface is illuminated with monochromatic light of wavelength lambda. So it is certain surface, obviously photoelectric metal, and light of wavelength lambda with which this is illuminated. The stopping potential of photoelectric current for this light is stopping potential, that is Vs. V sub S is 3V naught. This is stopping potential. And what is stopping potential? This is that negative potential of the anode for which the photoelectric current becomes absolutely zero. If the same surface is illuminated with light of wavelength 2 lambda, this is another light of wavelength 2 lambda is used, the stopping potential becomes V naught. This Vs, which is 3V naught, corresponding to this wavelength lambda, and this stopping potential V naught corresponds to this wavelength 2 lambda. The threshold wavelength for this surface of photoelectric effect is, so you have to find threshold wavelength. The work function of the metal is given by h mu naught. This is threshold frequency, and in terms of wavelength, this is Sc upon lambda naught. This is the threshold wavelength. This is threshold wavelength, and that is what you have to find. The threshold wavelength will be what? Now you have the equation. We have the equation, that is Einstein's photoelectric equation, which is given by Einstein's photoelectric equation. Einstein's photoelectric equation, which is the energy that we put in, appears in the form of kinetic energy max plus the work function of the metal. Now, if I write this in terms of stopping potential, this I'll write first or second, no problem that. This is E, the charge of electron, and V, the stopping potential, Vs, plus the work function is the energy with which the metal surface is irradiated. Now, I have this equation. I am going to use the general equation, that is EVS plus phi. First case, when the wavelength is lambda and the threshold wavelength is, the stopping potential is 3V naught. So for this situation, the equation will become E or Hc by lambda, whatever that I'm using, E equals to or Hc by lambda, because I'm using lambda and 2 lambda, so I'll write in terms of lambda and 2 lambda. Hc over lambda is E Vs. Vs is 3V naught here. This is our Vs, so 3V naught, so it is 3 times V naught plus 5. I have another equation. This is one. Another equation when light of 2 lambda is used and stopping potential is becoming V naught. In that case, this is Hc over 2 lambda. Instead of 2 lambda, this becomes E V naught plus phi. The work function of the metal is not going to change with different wavelength of light being used. So from here, I have to eliminate this V naught, then I have to multiply 3 and subtract from 1. So if I multiply minus 3 in this equation, or just multiply 3, then this will become 3 by 2 Hc over lambda is 3 EV naught plus 3 phi. This is the equation number 2, and that is 1. So this minus the equation number 1, this is, if I write negative of this equation, this minus Hc over lambda equals to minus 3 EV naught minus phi. This is equation 1 by multiplying minus 1. Adding these two equations, this will cancel out, and this will become 3 by 2 minus 1. 3 over 2 minus 1 is half. Okay, this is half. So this is AC over 2 lambda becoming, this is 2 of phi. 2 of phi. So it is phi is Hc over 4 lambda. Now I have the value of phi, which is Hc over 4 lambda. This is the equation I am getting from 1 and 2. The original equation formula for phi is Hc over lambda naught. This is the original equation. Work function is Hc over lambda naught. This is the threshold frequency. Threshold frequency. So this is, and that these two equations 3 and 4 are comparable, and comparing these two equations. So I have lambda naught is 4 lambda. This is the wavelength threshold frequency. So this is the threshold wavelength, and we are interested in threshold wavelength, not frequency. This is the threshold wavelength, and this threshold wavelength is asked. If I compare this with this one, then you can see that everything being same, only this 4 lambda naught is 4 lambda. Lambda naught is 4 lambda. So therefore the threshold wavelength for this situation will be 4 times the wavelength of light used in the first place. So the option number 4 is the correct answer to question number 24. Okay, thank you.